Hi dear students, welcome to statistics class. This is our module 2, topic 2, descriptive measures, measures of central tendency. Let's define descriptive measures. It is the values that are used to summarize the characteristics of a universe or population. And some of these are measures of location, dispersion, skewness, and kurtosis. The location, sometimes they term it as central tendency and dispersion as variation. So in the previous topics, we talked about the different methods of data presentation. It is just similar to a preacher, a presenter, a reporter, the way you present your information or your data. But today, it is just like before you present something, you have to get things or to get facts together before your presentation. So in other words, descriptive measures is like knowing or summarizing the characteristics of your data before you present it. So let's proceed. Measure of location. So it summarizes a data set by giving a typical value within the range of the data values that describes its location relative to entire data set. So sometimes they call it I believe you have already an idea what is the mean, what is your average grade, what is your vital statistics. Just by just giving a typical value, then you have already the analysis or the understanding of the data. Okay, so some of the common measures are minimum, maximum, and the measures of central tendency, percentiles, deciles, or quartiles. But we will talk only the measure of location, the minimum and the maximum, and the measures of central tendency. So what is this minimum and maximum? So minimum, by definition, it is the smallest value in the data set denoted as MIN. So it is mean. And then maximum as the largest value in the data set denoted as MAX or max. Say for example, what's the use of this minimum and maximum? So for example, someone would ask you, what is your minimum grade last semester? Then, for example, you will say 84. Then, oh, you're almost or just one step closer for being dense list, right? So you already have the idea of the standing of that person with respect to the population or to the data set. And then the maximum is the largest value in the data set. For example, what is the maximum number or grade you have last semester? Then if you will say 97, then the person, you will have the idea that, oh, this person is really some of his or her grades are just in from 890 to 97, or some, or the maximum, the maximum, his maximum grade or value would represent that indeed he's really capable to do or to get or to achieve such grade. So I believe you already understand this minimum and maximum by just defining or by just definition. So minimum is the smallest and the maximum is the largest. I think there is no problem with that, so let's proceed. So let's define the measures of central tendency is an index of the central location of a distribution, and it is a single value. Remember this, single value that is used to identify the center of the data or the typical value. Precise yet simple, and the most representative value of the data. So why do we need these measures of central tendency? So for example, in your church data, what is the tithes of the people or the brethren in your church? You don't need to say this family 1 has a 10,000 per month, this family 2 is 2,000 per month, this family 3 gives the 3,000 per month, this family 4 gives 5,000. So you don't have to enumerate every data values or your information. You just give me one single value, then I will have the idea of the characteristics or the capacity of your church. For example, the average tithe of our church members is 10,000. Then I will have already an idea, oh, this church is really bountiful. So, or this church is a tithe giver. So just by giving a single value, you can already identify or the center, you would know the center of your data value. So it is most representative value of that data. So we usually talk about this even in our just conversations, even our personal transactions, in a business transactions. Like someone would ask you, what do you think is the price of a laptop these days? So someone would say, maybe you should prepare by 35,000. Then at that typical value, so that is the information you have, and then you already know that you have to prepare that thing. Your friend should your friend would not tell you like this one is, some are 20, some are 3,000 only, some are 50,000, some are 60, but just giving you the average value, then you will have already an idea the amount that you're going to prepare. So that is the use of measures of central tendency. It gives you a single value and it gives you a typical value or the center of the data. By just giving you a single value, then you already have the idea of your data. Okay, so to further define it, it's values about which the set of observations tend to cluster. So also called as an average. So this is usually termed as average. What is your average grade? What is your average income? What is your average distance you walk every day? What is your average allowance? What is your average school fees? What is your average? So we usually use this term in many ways. So, and one of the commonly used averages are mean, median, mode, which I believe you've already have tackled about it in your high school or in your basic mathematics, the mean, median, and mode. And in this discussion, what we've learned previously in the summation notation will also apply that principles throughout our class. So don't think that our topic in a previous module as good as nothing. Remember that what you have learned there will be applied throughout these subjects. So even up to the last modules. So let's proceed. Mean, arithmetic mean. Okay, it is the sum of all observations in the dataset divided by the total number of observations. So in textual definition, so let's define it express it in a mathematical way. So just like in our summation notation, I believe that you can read this expression already. So this is the summation of xi, and then the index I ranges from 1 to n over n. So what is this? The population mean. The population mean for a finite population with n elements denoted by the Greek letter mu. So if I've used the term or this letter mu, then I'm talking about the population. That means my data values or my data set came a population. So and then from this, and then by just looking at this big letter N, then I'm already talking about the population size. But the computation with using the small n or the sample size, they're just the same. They'll just give you an idea that my data set came from a population. So let's proceed. Mu, or the population mean, is equal to summation of xi, where I ranges from 1 to n, over the population size. Okay, the number of observations, and then is equal to x1 plus x2 plus ellipses plus xn over n. Actually, this should be capital letter N because I'm talking about the population size or the population data. So where xi is the ith observation of the variable x and n is the total number of observations in the data set. Okay, so note that the population mean is a parameter while the sample mean is statistic, as we have defined in our basic concepts in the previous module. So now, what is the sample? The sample mean for a finite sample with n sample size, its sample number of observations using the samples elements denoted by x bar. Okay, so if I'm talking about if my data is uh, population data, then I will use the mu. And then if my data came from a samples, then to get the mean, I will use this x bar to signify that it is the sample mean. Okay, so x bar is equal to summation of xi, where I ranges from 1 to n. See that it is small letter n because I'm talking about the sample size or the sample over sample size or the number of observations, and then is equal to x1 plus x2 plus ellipsis plus or until xn over or divided by sample size or our n. So where xi is the ith observation of the variable x and n is the total number of observations in the data set. For example, given the number of children of a sample, remember, sample of 10 currently married women. So woman 1 has 3 children, then the next woman has 4 children, and then the next woman has 2 children, the 5, and then the 1 child, and then 3, 4, 2, 3, 3. So the question is, find the mean number of children of the currently married woman. So solution to compute for the sample mean, x bar, because I'm talking about the sample mean, x bar is 3 plus 4 plus 2 plus 5 plus 1 plus 3 plus 4 plus 2 plus 3 plus 3 over the sample size. How many women? It's 10, right? Sample size. So divided by 10 is equal to 3. So compute it and see that it is 3. The average number of children of married women is 3. So if someone would ask you, what's the average number of women in your number of children of women in your church? So you add that. So probably there are 3. So you will have an idea that women there uh, prefers few numbers or few number of children in the family. And then some properties of the mean. The mean is the most common measure of central tendency since it employs every observed value in the calculation. So every data value is included in your computation. And then it may or may not be an actual observed value in the data set. And there is only one mean in a given data set. So remember that there is only one mean. It is defined only for quantitative data. And I believe you understand this quantitative data, the numerical data. And it reflects the magnitude of every observation. It is easily affected by the presence of extreme values. For example, in our previous example, one woman there has 20 children. So of course, instead of 3 average number of children, you will have a significant or there will be changes, extreme changes in your average because of your extreme values. So the sum of the deviations from the mean is equal to 0. And now, what is this weighted mean? So we've already talked about the arithmetic mean, and now we will use this, or we will talk about this weighted mean. So what's the use of this weighted mean? But actually, when you compute for your GPA, grade point average, or GWA for some school, weighted average, so they use this weighted mean. For example, there are subjects that are 1 unit. So that means it's not a heavy subject. For example, the work ed. For example, in the the subject with laboratory, then you have the 6 units. So some subjects has a corresponding weights. So it should not be that they will be treated the same. So we use this weighted mean. So what is this? Let's define. Averaging the k quantities x1, x2 until xk by attaching more significance to some of the numbers than to others. We accomplish this by assigning weights, weight 1, weight 2, weight until k to the kth quantities where the weights represent measures of their relative importance. So mu w, because I'm talking about weighted mean, because if there is an absence or w, you cannot see the w here, then I'm talking about the arithmetic mean or the ordinary average, or x bar w to signify that is the weighted mean, is given by summation of wi xi, where I ranges from 1 to k. Remember this, it is the weight of x1. They are corresponding to each other. If the data value for this must have a corresponding or assigned weights over the summation of weights, or the summation of yi, where I ranges from 1 to k. So this is the total weight, where yi is the weight and the xi is the quantities. Okay. For example, what is the weighted grade of a student who received grades of 85, 76, and 82 on the 3 tests and a 79 on the final examination in a certain course if the final examination counts 3 times as much as each of the 3 tests? So by this problem, this final examination is how many times? 3 times more than this subject. So the weights for this is 1, the weights for this is 1, the weights for this is 1, and then this one is, weight is 3. So let's see that. So this is the corresponding grade. Weight, it's just 1. 76 is 1, and then 82 is 1, and then the 79 is 3. So that's the weights for that. And then by our previous, or in our formula, the x bar weight, or the weighted mean, is equal to summation of wi xi, where I ranges from 1 to k, over the summation of the total weight. So equal to 85 multiplied to 1 unit plus 76 multiplied to 1 unit plus 82 multiplied to 1 unit plus 79 multiplied to 3 units over the total weights. We have 3, 4, 5, 6. So 6. So 480 divided 6 is equal to 80. Then that is your weighted mean for that, or that is your the weighted mean of the student in this example. So I believe now you can compute for your GPA, so you will have an idea if you are in a cutoff of cum laude or magna cum laude. So I hope you will apply it. Then we have also other means. Combined mean, the geometric mean, harmonic mean. There's a lot of means in this world, but we will only talk about the arithmetic and the weighted mean, which will be useful in your student life. Now let's talk about median. What is this median? It is the middle value when the data values are arranged. Take note of this, arranged in ascending or descending order of magnitude. So it is the positional middle of the array. So from the word middle, median. So the median of your data set, if your data set is odd or the number of observations is odd, then the value of that is x. The value is from the total number or observations plus 1 divide 2. Then, for example, the third, then that becomes your median. So if n is even, then x n divide 2 plus x n divide 2 plus 1 divide 2, then that becomes your median. So in case 1, if the number of observations n is odd, the median is the middle observed value in the array. So take note that the first step in finding the median, or denoted by MD, is to arrange the observations in an array. Then you have just to look for the center or the middle observed value. And then for the case 2, if the number of observations n is even, the median is the average of the two middle observed values in the array. So example, number of times spent in praying per week of 14 CPAC students. So I have the data here. One person prays just once per week, and then some are twice, some are thrice, and fourth students uh, 4, and then the next is 5, 3, 4, 5, 7, 10, 3, 4, 5, or 25 times. They pray 25 times in a week. So to get the median, you have to arrange the datas or the data set or your data set in a ascending order or descending order. Okay, so to review in the previous, if n is odd, the center and then the middle plus 1. So that would be your median. So the median is 4 because we have 14, right? So that is even. So following this principle or this formula, we have here the 14 divide 2, that is 7. Okay, seventh values 1, 2, 3, 4, 5, 6, 7. So 4 plus xn divide 2. So 7 plus 1 and then 8. So the seventh and the eighth value. So 1, 2, 3, 4, 5, 6, 7. So 4 plus 4 is 8, divide 2 is 4. So the median is 4. Sometimes you can have the median which it's not all the time whole number depending on your data set. Now let's talk about the properties of the median. There is only one median for a data set. It is not amenable to further computations. The sum of the absolute deviations of the observations from a value, say C, is the smallest when C is equal to the median. That is summation of the absolute xi minus c is minimum when c is the median. So it's somewhat confusing, but you will understand it as you experience as you go through with some examples. So characteristics of median. The median is a positional measure. This implies that extreme values affect the median less than the mean because you will only count the odd or the even observed value in the positional array of your data set. So we use the median as a measure of central tendency if we wish the exact middle value of the distribution and when there are extreme observed values. Say for example, there are 1,000 times. So even if there's 1,000 times, it won't affect your median because you will only get the center of your data set. So now let's talk about the mode. Previous, we have talked about the mean, and then we have already talked about the computation of the median, and now we will talk about the mode. So the value or the values in the data set which occurs most frequently denoted by MO. MO is the observed value that occurs with the greatest frequency in a data set. So for example, most of the time, what is your mood, or what is your temperament most of the time? What is your feelings most of the day? Are you sad, very sad, sad, just no feelings, and then happy and very happy? So that is the mode. What is uh, the observed value or the characteristics that occurs with the greatest frequency? Okay? Determine the mode by counting the frequency of each observed value and finding the observed value. Okay, so for example, we have the book of the New Testament, Matthew, Mark, and their corresponding author. For example, in the book of Matthew, the author is Matthew. The book of Mark is Mark, and then Luke is Luke, and then Romans is, the author is Paul, until First Thessalonians. So Paul authored a lot of books in the Bible, and then James, Peter, and then Jude is in the book of Jude, and then Revelation, the author of that is John. So, okay. Example, let's recode. So, instead of using these characteristics for the author, we use the code as Matthew because we want to know who got the highest occurrences, or what is the mode of the authors of this book in the Bible in the New Testament. So Matthew is 1, that's recode. Mark is 2, Luke is 3, 4 is John, 5 is Paul, 6 is James, and 7 is Peter, and 8 is Jude. So this author, we will recode this as Matthew, we will put 1. So let's just say that's the number. Okay? So now we have recoded it. So Matthew, we have 1, Mark is 2. Oh, we can see here 5. So we want to know what is the mode of these data values. So in the 5 occurred 14 times. And Matthew occurred 1 time. And then Mark occurred 1. Luke occurred 2, John occurred 5, and Paul occurred 14, and James occurred 1, and Peter occurred twice, and Jude occurred once. So I will ask you, what is the mode of this data? 1, 2, 3, 4, 5, 5, 5, 5, 7. So we have the mode is 5 because Paul correspondingly has a greatest or the highest occurrences in our data set. So we can see here most of the authors are 5. Okay? So another thing to review, mode is the observed value that occurs with the greatest frequency in a data set. So given the data on number of leaves of plants, one plant has 2 leaves, another plant has 2 leaves, another plant has 1. What kind of plant is this with only 1 leaf? Anyway, it's just an example. And then 1, 1, 3, 3, 4, 4, 2, 2, 56. Oh, there's a grown-up plant because it has 56 leaves. But I will ask you, what is the mode of our data set? So the mode is 2 because 2 occurred 4 times. 1 occurred 3 times only. So our mode in this data set is 2 because it occurs with the greatest frequency in a data set. So let's learn the characteristics of mode. The mode gives the most typical value of a set of observations. So few low or high values do not easily affect the mode because, as I've said, it will just look on the characteristics or the value that occurs most frequently. The mode is sometimes not unique and does not exist. For example, they have the equal number of occurrences. For example, the 4 value appeared 10 times and the 5 value appeared 10 times. So you can have two modes, okay? And then we can have several modes for one data set. If there is one mode, it is unimodal. If there are two modes, we call it bimodal. If there are more than two modes, we call it multimodal. So the value of the mode is always one of the observed values in the data set. We can get, so unlike in mean and then media and the mean, sometimes their value didn't didn't have the exact or it's not the same with your data set, okay, because you just compute and get the center, while in mode the value or the mode of your data set must be one of your data set. So we can get the mode for both quantitative and qualitative types of data, just like in our example, the author. So qualitative type, so what is the mode? It is poll. If I would transform it to quantitative and recode them to numbers, then the mode is 5. So we can use the mode for quantitative and qualitative types of data. Note that it is determined by the frequency and not by the values of the observations. So before we end it, I would just like to remind you in Matthew 5:37, let what you say be a simply yes or no. Anything more than this comes from evil. Reminder, say what you mean and mean what you say. God bless you on your next topic.